Hello and welcome to my YouTube channel DNA Structure. In this tutorial, I am going to show you how to calculate base year by using equivalent static method and also by using response spectrum method. And later on we will do the same thing in Etabs and compare the results. To understand this knowledge, one must have basic knowledge in structural dynamics, earthquake resistance design of structure, MATLAB, Etabs, and IS 1893-2016. For this tutorial, I am considering simple structure which is 3 meter by 3 meter in plan and 3 story of each story 3 meter height. So the base year given in code is AH into W, where AH is horizontal seismic coefficient and W is seismic weight. So as per code in clause 3.26, the seismic weight is simply defined as half the dead load from the bottom story and half the load from the upper story and a specific amount of imposed load. So let's calculate the seismic weight. In our plan there are 4 columns. So the cross section of column I am considering here is 300 mm by 300 mm and height is 3 meter and unit weight is 25 kN per cubic meter. So the dead load is 27 kN. Similarly, the length of beam is 2.7 meter. So we have 4 beams. So the length is 10.8 meter and the cross section is same as column, that is 300 mm by 300 mm, and it comes as 24.3. Here the area of slab is 9 square meter and the thickness I am considering is 150 mm thick. So it comes as 33.75. Now the live load here I am considering is 2 kN per square meter. So according to code, if the live load is less up to 3 kN per square meter, then we will only consider 25%. Let's look this in code. Which is given in table 10, that is, if the load is up to 3 kN per square meter, then we will have to consider only 25%, else 50%. So here I am considering 25%. So if we add all this value, then we will get the seismic weight of ground floor, and the same goes for first floor. But for second floor, the height of column will be 1.5 meter. And here I am considering 1.5 meters. So the weight of column is 13.5, and for beam and slab, rest of the things will be same as for ground floor and first floor. So if you add all the seismic weight and the seismic weight of all floor, then we will get the total seismic weight of the building, which is 255.15. Now here we have calculated the seismic weight. Now let's calculate the horizontal seismic coefficient, which is Z by 2, I by R and SA by G. Here I am considering zone 5, so the value of zone factor is 0.36, which is given in code. It is given in table 3. So for zone 5, the value of Z is 0.36, and I am considering importance factor as 1.2 and response reduction factor 5, and these values are also in code. Let me show this. From table 8 we can find the importance factor, and from table 9 we can find the value of R. Here I am considering SMRF, so the value of R will be 5. Now to calculate the value of SA by G, we need the time period. So the formula for time period given in code is empirical formula, which is 0.075 h to the power 0.75. So by applying that formula we got the value of time period as 0.39. So the value of SA by G depends on time period, so we will use the code to calculate the value of SA by G, which is given in page number 9. So we'll use this clause A for use in equivalent static method. So here I am considering for medium stiff soil. So in the time period is 0.39. So 0.39 lies between 0 to 0.55. So the value of SA by G will be 2.5. Here y direction is not important, although I have calculated. So we have all the parameters to calculate the horizontal seismic coefficient. So if we use this formula Z by 2 I by R SA by G, we can calculate the value of AH. Now we can calculate the base shear by simply multiplying the AH and W, which comes as 27.56. So now let's do the same thing in Etabs and we'll compare the results. Here we have number of story as 3 and our building is 3 by 3 meter in plan, so I will take 3 meter by 3 meter spacing of grids. Now let's define the material. I will take M20, the grade of concrete as M20, and let's define the frame sections. Simply I will modify these values, select M20 and 300 by 300. Similarly, I will modify the column dimensions as well. Grade of concrete M20. Now define the slab section. Simply I will modify this M20 and the thickness of slab is 150 mm thick. So now let's draw the model. First I will draw for ground floor and replicate it. Now also draw the slab. Now I will assign the live load as 2 kilonewton per square meter, which we have used for the calculation of seismic weight. Now I will replicate the story. Now let's assign the support as fixed support. Now we'll define the seismic force, which is equivalent static method. Select seismic and IS 1893/2016. Here the y direction is not important, although I am defining. Now let's modify the force in x direction. Simply select x direction, and our importance factor is 1.2, soil type 2, Z 0.36, and R value 5. And same goes for y direction. Now let's define the mass source. Simply modify and click on specify load pattern, and as dead load as 100% and live load as 25%, which we have used for the calculation of seismic weight. Now save. Now I think I have done all the things, so let's run the model. Now we'll see the results. Go to load pattern definitions and select load pattern definitions auto seismic IS 1893/2016. So the time period calculated by Etabs is 0.353, and in our manual calculation it is 0.39, which is quite close. And the seismic weight used by Etabs is 255.07, and in our calculation it is 255.15, so it is also quite close. And base year calculated by Etabs is 27.54, and in our manual calculation it is 27.56, so it is also quite close. Now we can say that Etabs is a very much powerful software, and it also matches with our manual calculation. So I think this concludes our first part, and in second part we will calculate the base year by using response spectrum, and we'll compare it by Etabs. So thank you.